Hi everyone, welcome back. If you're appreciating what I'm doing, please just press like and subscribe if you can. The videos on sine and cos can get quite tricky, and that's where it mucks up a lot of students. If I want to make some questions that cause most students to have a problem, these are them. And yet they're very typical of what you can get in Year 12 exams. Most of Australia, I've taught in 3 states of Australia. You can get them over and over again. You get this concept here. It's that 4 there that causes the problem. That 4, for some reason, causes a lot of people's brain to almost melt down. I feel like going a really long version of this without trying to take too long. If I wrote that as 15 bracket sine x to the power of 4 cos x, and I've written it out like that, instead of putting the 4 there, the 4's up there. That just means that. People get sick of writing the brackets, and it's pretty obvious. If you put a 4 there, that you mean sine x by sine x by sine x by sine x. Now, some of your brains will click in now, and I'm going to use up the room over here, where I'm going to talk about this is the reverse of the chain rule. So what do we mean by the reverse of the chain rule? What's going on there? It means that we're going to increase that power to a 5. So let's write down what I'm saying. Let's say you don't understand this yet. Give me a chance. Hang in there. It takes a while. So if we wrote that sine x to the power of 5, see, if I was differentiating with a power of 5, I'd go 5 times the front and decrease the power by 1. So what's happening here is that we're only talking about what happens to that sine x if it comes to the power of 5 and you divide by 5. But there's also this cos x here. So what does that have to do with what's going on in this question? Well, I still talk about in previous videos, I say to my classes, the cos x is there for the ride. The 15x is there for the ride. The 15 makes the graph steeper, 15 times dilated vertically, up and down. But then it gets too complicated to talk about that. So we're going to talk about that's there for the ride. Don't forget to put plus C. Need to put plus C, and depends on where you are. You could lose a mark for not writing it in. Now, here's the most annoying part of all. A lot of people get comfortable. That means a 4th power, make it to the 5 divided by the power. Then you've also got to divide by the derivative of the inside. So if you've done the reverse of the chain rule, I've got a couple of other videos. If you want to have a look at them, there's videos on the reverse of the chain rule, and this is very particular ones that muck people up. Now, we've got to get the derivative of the inside. So what's the derivative of sine x? And over here I've got my little circle. Sine x becomes cos, cos becomes minus sine, minus, and etc. And you can go around if you differentiate. Interesting part in the middle of integrating, we are differentiating, which is we're undoing the process of what would have happened if we were differentiating. So how do I differentiate sine x? Sine x becomes cos x. So I'm going to put a multiply there and put the cos x there. And the reason this question works is that that cos and that cos are going to cancel out. If they don't cancel out the x values with the cos, this system, this method won't work. And there's methods of doing that. There are ways to do that when you get into the specialist course. Those who do, or when you get to uni for higher level questions. So this one, I always say to people, does the outside there, including the 15, don't have to worry about it because it's just a multiple. Does the outside look like it's the derivative of the inside? And you go, yes. Cos is the derivative of sine, or looks like it could be the derivative of sine. Let's have a look at the question here and see what's going on. So the cos will cancel with the cos. The 5 will go into 15 3 times, and we've got 3 sine x to the power of 5 plus c. So if I come along and I said, let's double check and see if we've got this right, that's actually 3 sine to the power of 5 plus c. So if I come along with a function, I said I've got 3 sine 5. And you might notice this. Who cares what that number is? It doesn't matter what it is. Let's say it was 100 to make it a little bit unusual. If I said differentiate that, what do you do with the power? 5 times 3 is 15. That's where that 15 comes from. And then you say decrease the power by 1. So the 5 becomes a 4. So we've decreased the power by 1. And then we times by what I refer to as the derivative of the inside. So the sine x, we multiply the derivative of that, and that's cos x. Imagine trying to prove this. If you've done first principles, it's a bit revolting. And the 100 becomes 0. So if I differentiate that expression, no matter what that number is, I'm going to get 15 sine with a 4 and cos. So go back to the question here. I got 15 sine with a 4 and I've got the cos. So over here, I was multiplying by the derivative of the inside. So go back to here. This is the big one here. I've got to divide by the derivative of the inside. Because we're reversing that process. Now, by the way, if I had more here, for example, like a square root of x, it becomes the product rule. If I have divided by something with x, it becomes the quotient rule. So it can get more and more complicated, but these ones here just so happen, this one here, because the outside looks like it's the derivative of the inside, is a simple reverse of the chain rule. Now, some of you watching me won't go, that's not simple. So if you're okay with the first one, let's go for something that looks pretty revolting. Only reason it's going to work is it looks like sine 5x minus 7 is the derivative of cos. It can be a multiple of it, it can be a factor of it, as long as it looks like it could be the derivative. Non-thinking, I call it non-thinking approach. Other teachers will teach, take out the common factors and do all sorts of things with it. I don't do any of that. I just look at this and I go, the cos has to become a power of 4. 5x minus 7 stays the same. Sine 5x minus 7 is there for the ride, and I know I'm going to put plus c. The other thing I'm now talking about is that evil integration divides. So we can have all sorts of division going on here. Let's have a look what the division is. We're going to divide by the power, which is the 4. And now we're going to divide by the derivative of the inside. So the derivative, I'm reading about it, it's quite crazy. The derivative of the cos of 5x minus 7 is cos becomes a, when you differentiate it, a minus sine. So we're going to times by minus sine of 5x minus 7. Now there's a derivative of the inside of the inside. That's the big one here. For some reason, yeah, I don't know what reason, lots of people, it doesn't make sense to their brain. So this has got another times by 5. Now the question is actually finished. Then you want to tidy it up and see what's happening. The only reason this method works is because all of that sine 5x minus 7 will cancel with all of that sine 5x minus 7. If you get to uni or if you're in a higher level course in specialist in Australia or in another country, if this section here with another x value in it doesn't cancel, this method doesn't work and you need another method. Usually things like substitution and trig identities to change the form of the question. Let's have a look what's happening here. I've got two negatives, make a positive, I don't have to worry about them anymore. All that sine 5x minus 7 is gone, don't have to worry about that anymore. So I've got a cos to the power of 4 of 5x minus 7. I've got plus a constant, and then I've got this big part here, the 6 and the 4 5s are 20. Most people are okay. I could just cancel that as 3 and 2, and I'm left with 3 on the top. And if I wanted to, I could put the 10 on the bottom. There's no need to write the negatives because the two negatives make a positive. There's a question though. Be interesting to differentiate that because that will give us that. Now, for anyone that's okay, don't watch anymore, that's enough. Some of you might want to come back and watch that tomorrow and see what's going on. Watch it again. So if I go through a differentiator, let's have a quick look at what's going on. I'm still going to talk about, a lot of people need to see, even those who are good at their maths, need to see that really, that's the cos, all that to the power of 4, plus a constant. And I put square brackets back here if you don't understand. Curly brackets, parentheses, and then the next set of brackets are normally square brackets. Historically, that's the rule brackets. These are called parentheses. Let's have a look at it. Differentiate it. And this one here is a chain rule. How do we know it's a chain rule? It's got an expression, a function I should say, an expression in x or a function in x with a power. So we know that the power is you go the top by the front. So 4 3s are 12, and the cos of 5x minus 7 becomes a power of, and I'm just going to go those brackets. Power of 3 times 10. Now we've got times by the derivative of the inside. So the derivative of cos becomes minus sine of 5x minus 7 times by an extra 5, and the c cancels out. So all this stuff that's going on here, that's when most people forget when they're differentiating a chain rule. We're now doing the reverse of the chain rule. So have a look at what I've got up here. That 5 cancels with the 10, becomes twice. The 2 cancels with the 12 and becomes a 6. we got this minus or a negative. I went back to where we started, minus 6. And I can go cos, and I'll get rid of all these extra brackets, cubed, 5x minus 7. And now you can see where that extra 5x minus 7 comes from. It comes from the derivative inside. By the way, if we didn't have that 5, extra 5, this would not have become a 6, or a negative 6 in this case. So that comes from that. And if I differentiate that, I go back to where I started from up there. So integration and differentiation being the reverse of each other. I hope it helps. That's getting a bit crazy and long-winded, but it can happen in exams and in your assessments more than likely, and in your mock exams. Thanks for watching. I hope you enjoyed it.